Hello everyone, welcome to iExamB. Please subscribe to the channel and press the bell icon so that you do not miss any updates on our upcoming videos. In this video, I'm going to talk about a very important theorem, which is the Central Limit Theorem, and this is very relevant in the statistics and econometrics portion. If you're struggling with statistics and econometrics, then you must watch this video till the end, as I am going to explain you this theorem by telling you a very small story. And this particular topic is also important for your upcoming RBI Grade B DEPR examination. So the dates are tentatively 8th of April, as we know, because on 8th of April the DSIM exam is likely to be conducted, and it's a possibility because DEPR and DSIM is conducted together, so it's likely that the DEPR would be on 8th of April as well. If you haven't yet started the preparation, do not delay further, start now. So let's look at this Central Limit Theorem. So this Central Limit Theorem basically tells you about the distribution of your sample, that what kind of distribution your sample will have if you collect several samples from a particular population. So before understanding what would be the kind of distribution the sample will have, first let us understand a very important concept called the normal distribution. So normal distribution, as the name suggests, is a very normal kind of distribution. It is symmetrical from both sides, and it is a bell-shaped kind of a distribution which has only one mode, and the mean, median and mode are all the same at the middlemost point. That kind of distribution is called the normal distribution. Now what the Central Limit Theorem tells you is that, let's say there are different kinds of distribution which your population has. It is here in this it is negatively skewed, in this it is positively skewed, it is some other kind of distribution, and this is uniform. So whatever be the kind of distribution your population has, if you collect several samples from the population, if you are collecting different samples from this population, then from this particular population, and then from this particular population, and then this also, and then you find the mean of the different samples that you have collected. So the distribution of the sample means would follow a normal distribution. This is what the Central Limit Theorem tells you, that you have found x bar 1, x bar 2, x bar 3 and so on for the different samples. Now this distribution of these samples mean will follow a normal distribution. But why is this so? That why does this happen, that if the population distribution is any distribution, there's no restriction that the population should only be normal. It could be any distribution. So as you collect samples of size n, the sampling distribution of the mean will be a Gaussian or the normal distribution, which is the same thing, and it will have the mean mu, which is equal to the population mean, and it will have the variance sigma by root n, and here sigma is the population variance. Now why this happens? Because as n becomes large, as n tends to infinity, the distribution, the sampling distribution will follow a normal distribution. So there is a limiting case that as n becomes large and large, the distribution of the sample means will follow a normal distribution. But let's understand that why would this happen from a story. So suppose there is an economist and he wants to study rabbits. He goes to a forest and he wants to study the wild rabbits there. So he basically wants to look at the distribution of their weights. So now he is sitting under a tree and he is measuring the weights of all the rabbits in the forest one by one, and he is recording the data in his Excel sheet. Now we know that the distribution of the weights will follow a normal distribution or a Gaussian distribution when you enter the weights of all the rabbits in the forest. But obviously doing this work will cost him a lot of time and a lot of money as well, plus he might have to give some carrots to the rabbits as well. So this will cost him a fortune. So obviously doing this is not the wise strategy. We're measuring the weights of each and every rabbit. So instead what he does is that out of the total population, total rabbits, he is now going to pick samples of a certain size, of size n, and then he is now going to measure the weights of only those rabbits. And he's going to collect many samples because he knows that one particular sample will not be representative of the whole population. So that's why he collects many samples out of this total population of rabbits. So initially maybe he weighs 5 rabbits at a time and then records their weights. Then he further moves to weighing, let's say, 25 rabbits and then records their weight. Then he increases the sample size further and let's say measures 40 rabbits and records their weight, and so on till let's say he records the weight of 100 rabbits at a time. So what is seen is that as the sample size increases from 5 to 25 to 40 to 100, the spread of the distribution starts to decrease further and further. And the distribution of the average weights, it becomes more and more normal. So what this economist has just demonstrated is your central limit theorem. But what if the distribution of the population is not normal? Then what happens? So even in that case, for example, let's take the example of dragon wingspan. If you take this distribution of their wingspans, then we know that the distribution of the dragon wingspans is bimodal. That is, it has 2 modes. So it is definitely not normal. Now if you measure the weight of the wingspans, the distribution of the average wingspans that you will get would still be normal. So what the central limit theorem suggests is that irrespective of the distribution of your population, okay, whatever be the distribution of the population, if you collect a lot of samples, that is, as n becomes large enough, the distribution of the sample means would tend to a normal distribution. So now we know that regardless of the true population distribution, the central limit theorem shows that the average values drawn from that particular population distribution would tend to a normal distribution. And also, as your sample size as n becomes large, then the mean of your samples, which is x bar, will tend to the population mean mu. So to put it formally, the central limit theorem states that the distribution of a sample variable approximates a normal distribution, that is the Gaussian distribution, which is a bell-shaped curve, as the sample size becomes larger. So assuming that all the samples are identical in size here, and regardless of what the distribution of the population actually is. So I hope you now understood this central limit theorem really well. You can look at this successful students strategy for this year as well as for last year, and if you wish, you can also visit our website and enroll for the course. If you have further any queries, you can call on this number, or you can also email at this particular email ID. Thank you so much.